So welcome to this video about the Starship from SpaceX. Guess what? On June 6th, SpaceX sent Starship into the space for the fourth time. And this, I think, is its best success so far. So let's see what happened on June 6th. I'm going to give you an idea of everything that has happened so far. You'll see it is exciting. So from here, let's see if I can make this image a little bit bigger like this. Can we make it even bigger just for fun? Excellent. So here you can see that. Okay, so how come it's not happy? Let's double check here. Very nice. Good. So here we are at 1 minute 34 before launch. And as you can see, we've got the control center all ready to go. We have here, it's a bit foggy outside, but because we have some of the fumes coming from here. Keeping in mind that we have the Starship here that is standing on its main engine to leave Earth's gravity. Now, here we're using methane and oxygen. So that this is the best way to be able, first of all, to have an engine, a rocket that is easily made. Second, we can reuse it fairly well, and it's so much easier to refurbish it for the following flight. So that's the reason for this one here. So we have here our video a bit blurry. It's coming back, so that's excellent. So here I went forward a little bit. So here, in a moment. So we have 8 seconds. So let's see this launch from the Starship from SpaceX. So here you can see all the engine here turned on. Let's see if I can change a little bit the view to here. So here we had all the engine that turned on. We have the Starship that is leaving. You could see here how cold it is outside. And here we have the rocket spaceship was launched. As you can see on the side here, you can see one of the rocket engine here did not work properly. However, there's no issue because we had computers that made sure things worked out. You can see here there's some brown smoke here. That's an example of how using methane and oxygen for the rocket booster, it works beautifully, but it creates more pollution than if you have the mission, for example, Artemis, that are using hydrogen and oxygen. There you go. So here's a great picture from all the rockets at the bottom here, and you could see that one was not lit. So you have here the example here, but still the launch was a success, and that became something that did not affect the run of the launch. So let's continue. As you can see, after 5 kilometers in altitude, we're almost close to 1,000 kilometers an hour, and it is a beautiful launch. So I'm very proud of SpaceX here. I'm going to move it for a few minutes. So we are going to 4250 till about here. So let's see if we have, so by the way, this is taken from the X, so previously Twitter, and this is the SpaceX account. So here we have the rocket right here. As you can see in a moment, we're going to have the bottom rocket booster that will separate from the Starship. And look at this, beautifully done. And then we have here going, and then we have the rocket going, being separated. So right here, you could see at the bottom here. So we have a rocket that is now ready to come back to Earth, and we're going to see how well it went in a moment. Otherwise, we have the Starship going up. We have here that small winglet here to make sure it helps with guiding the rockets. And here, these parts here are also used to direct it. As you can see here for the bottom portion, we see that it's still at about 100 kilometers of altitude and slowing down nicely. So it is going through the atmosphere until it gets close to its landing site. So let's see if we can go to the landing site in 4 minutes from this point. I have 47 minutes after launch. Not 47 minutes, but about 5 minutes after launch. So I have 47. I think that's fair here. Excellent. So here, as you can see on the left side, so here on the right, we have the Starship. On the left, we have here the booster. As you can see, it's going down. We're at 5 kilometers from the surface. We have here this side here, making sure it directs the engine. As you can see, no engines are up yet. And oops, we are lighting them up because in order to bring it down, we have very little or minimum fuel, and we need to maximize that. And as you can see, you have the ocean surface here. So these most likely will land on platform on the ocean. You could see it slows down to 0, going up a little bit, and to have a controlled landing. So that is the main thing. And I'm going to stop it right here. So as it landed exactly the way it wanted. So here we have the engine that are cut off if it was on a platform, and here we have the booster rocket falling in the water. So this first part is an amazing success. So first of all, the rocket booster was used to send Starship up, and now we can control its return. This is an amazing success so that we can maximize the reuse of this booster rocket. So I'm very proud of them. During that time, so if I go back, so here as you can see, it's landing in water for recuperation. So now we have our Starship into space doing its work right here. Now it spent, I think it was 45 minutes to 50 minutes, and at some point it got ready to come back to the planet. So I have here at 1:21. So let's see if I can go here. Perfect. Perfect. So at 1:21, so here you could see it's coming, it's directing back. So we're at 41 minutes here, and we are going down in altitude. Here we're going at 26,000 kilometers an hour, and here they show what's going to happen. It's going to go into the atmosphere, use the pressure from the friction of the atmosphere, and what will happen is that very quickly it's going to slow down, and after that, as it gets close to a much slower pace, it's going to get closer here to the surface, landing on water, and very quickly it's going to go vertical, and then very quickly it will land where it's supposed to be. Keeping in mind that the quantity of fuel is much less, making the rocket much lighter. So here you could see, so we have this winglet here at close to the bottom here. It shows how great it is. You can see that we have this small hexagon. So we have the tiles that is protecting the integrity of this winglet here. And you could see there's a hinge here to make sure we can play and use it nicely. So I'm going to bring it a couple minutes to see when it starts to come into the atmosphere at 1:28:43, no, 1:45:43. How about here? Let's see if I can go back to Twitter and back to full screen. So here you could see how we have our rocket that is getting back into the atmosphere. You could see here on the belly, we have all these thermal ceramics tiles all in hexagon to protect the rocket. And you could see how the friction here is increasing the temperature and ionization of the atmosphere. And you could see here the wing is up to minimize the friction. But right here, there is an increase in friction as it comes down. So that's the first thing we're going to see right now. I'm going to go forward a little minute at 1:27 or so. And here you can see how much the friction is increasing. Let's see if I can make this a bit bigger for you. So we have the friction getting bigger here, and you can see how it's more and more glowing. So what's happening here, we have the Starship coming down on its belly, and then you have the friction of the increased density of the atmosphere as it comes down. And here it creates friction, creates pressure, and therefore ionizing the atmosphere right under the belly here. And you can see here, this is slowing down. And here you could see how this wing here is creating a disturbance a little bit in the way it is. But this is important because this will allow Starship to be more controlled as it is landing. So I'm going to go to 1:35. So I'm going to go here 7 minutes in a bit later, and you'll see that the pressure keeps on getting more and more. 1:29. You can see more and more pressure, and more pressure. And we're going to go at 1:35. So let's start here. So here you could see the density of the atmosphere got much bigger. Here we had a lot of disturbance, and until we found the best. Okay, let's bring it back a little bit. It's just a beauty. So let's see. So here, look at the disturbance right here until it stabilizes the perfect direction to minimize turbulence here. And look at these lines here, the flow line of the atmosphere past the Starship right here. Now here you can see on this winglet, you can see here there's an increase in temperature right here. So there's a junction, there's a hinge right here. So here, the hottest part, but it's protected from the tile, so we're doing great. And we have here some of the flow of ionized atmosphere. You can see here, there's still a low pressure area here. So imagine how much pressure there is on this part right here. So very nice. So I'm gonna bring it forward just a tiny bit, to a couple minutes, to 137. 137, a little bit more. Perfect. So here you could see a few things that was interesting. So here again, you can feel, you can see how much more heat there is, but it's uniform here on this wing. The wing is moving forward a little bit, increasing the friction. And here you could see on top of the winglet, there's another camera. And you could see how much heat is right here, the disturbance here in the flow. And you could see how much the temperature is right here. But you'll notice at some point that because of the heat, some of these tiles will start going. Some of the metal that was covering the structure of the winglet will start to melt, so because it's so hot. However, I have to say that the engineers that put the structure together did an amazing job. Because even though, as you can see here, some of the parts are slowly going away because of the heat, because of the pressure, we still have a great integrity of the structural part here. So this is a weakness in the system, but it is still doing the job as it's supposed to do. So look at this here. So here we have the parts that are over, just melting away, but still keeping the integrity of this wing right here. So it's quite amazing. And you see here some of these tiles just moving away. They were possibly just glued on the metal, but temperature being so big, it is still good. So we're at 50 kilometers from the surface. We went from 26,000 kilometers an hour down to 14,000 kilometers an hour. So still slowing down. So here, no engines are going forward. We're just using the winglet and some of the parts around the rockets to slow down. And as you can see, so many particles have been out of this winglet that here the camera, it's much harder to see what is going on. But you could see there's still a glow, so things are still there. So imagine how the engineers were a bit worried when this happens, but it's still held together. So I'm quite happy with how things are right here. So I'm going to go forward for another 4 minutes. And then we are at 25 kilometers from the surface, so 143. So what do we have here? So let's see, I'm gonna shrink my image. I'm gonna go back. So here, the camera, we can still see a lot of it is covered. So we have dust and we have particles hiding the field of view. But you can see here that even though the winglet is hot, look at the edges here. The structural integrity of the winglet is still there. You can see here, this edge here is still very hot and some parts are right there. However, it's still holding up and still doing amazing. So if you look at the altitude, we're now at 20 kilometers from the surface and 1,000 kilometers per hour. So this friction slowed down the rocket quite a bit and it's quite amazing. So here now we had the last bit of that fourth test on the Starship. First of all, we need to land it. So they're landing it. They landed it on the water, like for the main rocket boosters, just to make sure that everything will be okay and there'll be no breakage of the infrastructures. My guess is that they will put together some barges and they will land them on platforms on the water. But here we're at 11 kilometers from the surface. We're at 600 kilometers an hour. We still have the structure right here. You could see here the winglet is moving. So they're just testing to make sure they're working well because they need it. Because if you look here, we have the Starship that is horizontal. And very quickly, they're going to have to put it vertical so they can land it. So this is what they're going to have to look into. So here the winglet is moving. So that's the main thing. It is still very hot. Look at the color of this. Ceramic tiles have just been unglued. They're off. Many of the metals is gone. We can see a little bit more, which is exciting. So we're at 5 kilometers from the surface. And very soon, what the rocket needs to do is that, so that it's slowing down, it's like free falling. Very quickly, it's going to go up like this. And at that time, they will start the rockets of the Starship because they are just using exactly how much fuel they have. That means that they need to maximize that fuel. So they use many of it to control it into space. They use the atmosphere to slow it down. And very quickly, so here we're at 2 kilometers. They're using it here horizontally to guide it where they want it to be. Now it's going to be very soon going to vertical stage. And here I thought they would put here the rockets to see how it works, but they didn't do it. So here we're at under kilometers. We can see the winglets are working. It's not vertical. And it's going to go to a mode of 0. It's going to go up a little bit. And then it's going to land perfectly well. You'll see once it is where it's supposed to be, it will just fall down in the water. And this is an amazing success by SpaceX. Now you're going to see, well, they lost the integrity of the winglet. That is true. However, think about the technical advancement they had to do to be able to do that. Think of the know-how of all the humans in that team to make sure that this happens. Overall, this is amazing because this success will make sure that once we put human in the Starship, they will be safe. And that's very important. The Starship is planned to be used for the Artemis mission to bring some goods to the moon to make sure that when we have humans going there, they will have the resources to maximize their trip. That is exciting. And that will be our first topic for today with respect to SpaceX. Congrats to them. It's amazing. The second topic we will be looking into today is the fact that Boeing has its project as well. So SpaceX started earlier. Now we have Boeing that have been working on the rockets called Starliner. Now here, this was a crewed test. So that means that for the first time, Boeing was using their Starliner to bring astronauts to the space station. And then again, this was another amazing success this week. So here we're going to go to 3 hour and 15 3 hour and 15 like this. So I'm going to show you a few pictures. Just amazing how they look. So here we have the space station. Oh, let's see if I can make this a little bit bigger for you. So here we have a camera from the space station. It's right here. And we can see here the module with the 2 astronauts that successfully went to space. So that was the first key success. After this success, what they needed to do, so very slowly, they brought it closer. I have some, I like this one right here. Look at this, how amazing this looks. So we have here the capsule getting close to the space station, and you can look at the shadow here, how they are moving. There's a little wave here. I think it's a little bubble head, I think. But here we have the module getting closer and closer to the International Space Station, giving Boeing an amazing success with their program. Because here so far we had governments like the European Space Agency, we had Russia, we had, I think there's another country and I just can't think of it right now. But anyway, we have now Boeing, that is another private company that is sending 2 privately trained, no, so the astronauts here on the capsule, they were working for NASA for a while, and now they are no longer astronauts for NASA. So they're hired by Boeing to be able to carry out experiments, carry out their programs. So here, when you say that NASA is retiring astronauts, it doesn't mean it's the end, because we have now private companies working on these. So this is quite amazing. So we have here at 4:48, so an hour later, we have this amazing picture. Look at this, how it's just great. So after an hour, it got closer, we aligned the capsule, and they were able to make it here. So here they had to work on the fact that, first of all, the capsule had to dock. They had to have a holding together. Then they needed to take care of the seal to make sure that there's no gas losses between the capsule and the International Space Station, because that's important, because we want transfer of astronauts to be safe. So we are going to go to 6 hours and 6 minutes. So for an hour, they were looking at how everything was going, making sure the seal was good, preparing the astronauts, taking their suit off to be ready to meet the people in, oops, there we go, in the space station. So here we could see, so it took a while. People here, the astronauts on the space station were not sure when they were coming out, and there we go. They're doing the last test to make sure things are good, because it is part of the experiment. And what do we have? We have 2 new astronauts by Boeing, meeting the 7 current astronauts on the space station. So it's quite exciting, because the 2 astronauts here were in isolation since the Starliner was supposed to go. Look at this first astronaut, very excited. Look at this. And look how the rigidity of the hair and probably a bit of static electricity are making the hair just looks like it's floating. And here we have second astronaut. So here it was probably for about a week or 2 where the astronauts from Boeing were isolated for the launch. Very happy to see humans. And it was a project that was several weeks, several years in the process. So here I have to say that I'm very proud of Boeing as well for their project here. So it's quite good. I'm going to put the links of these videos in the descriptions below when I edit this video here session today, which is exciting. We will have our third project today. So the third project today is about China. Look at this, how beautiful this look. So on June 1st and 2nd, we have a Chang'e-6 come on, the wording, it's going to come out. So on June 1st and 2nd, we have the Chang'e-6 module that landed on the moon. So in May, we had the launch. We had here the object here, the equipment that went around the moon for about 20 days, making sure that everything was going well. Second, making sure they would be able to land where they wanted to be, keeping in mind that the landing happened on the far side of the moon. So the Chinese government, the Chinese program, in order to make this happen, had to have a satellite that was orbiting the moon at all time to allow for communication. Because once you're on the far side, there's no communication with the rest of the planet. So that has been one of the big challenge. So here, this is the Chang'e-6 program. So they had a Chang'e-5 program in 2020 where, oh, look at this, you're not even seeing that. There we go. So you had the Chang'e-5 project. They went to the moon on the visible side. They had also a landing. They had a similar project. And you know what? I think Chang'e-5 was the original and Chang'e-6 was the spare, the backup plan, that because the Chang'e-5 was a success, Chang'e-6 could happen. So here Chang'e-5 went on the near side of the moon, picked up about 1.7 kilograms of rocks and soil, and brought them back to Earth. So this one here is to bring back soil from the far side. So here it landed. So here you could see the track. Let's see if I can make this a little bit bigger so you can see. So you could see here you had a little module, a little rover of some kind that came this way. And here we can see its shadow taking an amazing picture of this here. So you could see here, this was the landing equipment. On the top, you have the top part, which I will talk about in one moment. You have here the little flag from China, which I'm very proud of for them. And we have the arm here that went to collect the sand. So that's the first thing that is interesting. So let's see if we can go on their website. Let's go to the first picture. So here we have the same picture from China, and we have here collect of sand. We have here the leg of the lander, and then we have here the flag. Very proud of them. And then we have a picture of the lunar surface. It's very uniform looking. And then we have the team from China, and we can see that there is collaboration with another country. So going back to this one here, so there's a few parts related to this project. So is it this one right here? So Chang'e-6. So here the mission is made out of 4 parts. The first part was to send Chang'e-6 into space in orbit around the moon. And then there was, and this was quite heavy. It was like 8,200 kilograms for the rocket and ever so on. We also had a payload for all the equipment of about probably 4,000 kilograms. So the lander ended up going to, first of all, landing on the moon. So that's the first thing. Once it's on the moon, it's collecting the samples with the arm right here. And then the sample was to be put on the upper part here of this lander. This upper part here is a separate piece that is able to leave this landing part so that we can bring sample back to Earth. So for that upper part is called the ascender. So the ascender here, the goal is to leave the surface of the moon, the gravity much smaller than Earth, and to go back in orbit to the orbiter. The orbiter is orbiting the moon, and it was a good place for this ascender and the sample to dock and make sure that everything is good. This will last for a couple days, couple orbits around the moon, and when it's ready, then there will be the returner. So that will be this capsule that will bring back this sample back to Earth. We don't know exactly how much soil and rocks and dirt will come back. We'll see how it goes. Can I say dirt? That's a good question, because when you can think of dirt, you also think of living organisms. So let's say soil and rocks. We'll see what happens, and we still don't know how much they will bring back, and that is exciting. So here you can see we have, so let's see. We have this one here, the Chang'e-6 mission. The samples took off from the surface on June 6th. So let's see what this will bring us in the next few weeks. So they're expecting probably that the rocks will be coming back to Earth from the moon, maybe June 10th to June 12th, and then it will come back and for re-entry in the atmosphere at some point in a week or two. And that is basically the end of our show today on different topics related to space exploration. We have 3 groups that did amazing work. There's SpaceX with their program of Starship, Boeing with their program Starliner, and we also have China with their project Chang'e-6. Hopefully you've enjoyed this. I'm going to put here a link to a video that I did on Chang'e-6 when they sent the rocket to give us more information about the project, and I'll see you in the next video.